My name is Satyadi. We are at UCLA in Los Angeles, California, and I'm a part of the UCLA iGEM team here. So iGEM stands for the International Genetically Engineered Machine, and what we do is we are a synthetic biology research team. So our overarching project theme is synthetic silk, and there's like a lot of different components to the silk. We can use it for like sutures. I've read things about skin grafts, replacement hearts with all these synthetic silks. It's an amazing fiber. It has amazing properties. It's extremely elastic, extremely strong. So it can be used for a lot of different applications. So I'm from a town in the Bay Area called San Mateo. When I was in second grade, my grandmother was hospitalized down here actually in Los Angeles. I asked my parents, what's wrong with grandma? And they say, oh, she has stage 4 pancreatic cancer. And second grader goes, what's cancer? And then my parents, being the encouraging parents that they are, say, why don't you go find out? So when I came back to the Bay Area, I went to Belmont Library. I go up to the lady and I asked her, can you find me 10 books about cancer? And she goes, why do you want to read about cancer? It's so sad. And I was like, I want to learn about cancer because I want to be able to find a cure so people like my grandma don't have to die. You know, it's not just my grandma, it's someone else's grandma. It could be me, it could be my brother, my mom, my dad, it could be my friends. It's something that motivates me to learn more and to be able to seek these answers because they're questions that no one has the answer to yet. A lot of people are working on spider silk right now, but a lesser known silk is actually honeybee silk. So that's the project that I'm currently working on. So I've basically been trying to synthesize synthetic honeybee silk by cloning and getting the genes that honeybees use to make the silk in their hives, and I've been cloning into E. coli to try to produce it, and we're going to try to functionalize it and characterize it, make it glow, attach different kind of tags to it that we can use for a lot of different applications in biomedical industries. So I'm basically the main cloning person. So cloning involves taking a fragment, an insert of DNA, and trying to make it into a functional plasmid. Using the blue light box and the gel imager allows us to see the DNA fragments on an agarose gel, which allows us to see, so we can actually visualize the DNA.
So basically you're like doing Spider-Man work.
Essentially, yeah, except I'm doing honeybees. It's really cool because I came to UCLA and I thought, oh, I'm just gonna join a research lab, but instead I joined this team, and it's so much more than just working in the lab with a graduate student or a PI. We all interact with each other, we all work together all the time. We're constantly asking each other questions, like feeding ideas off each other, and it's very integrated, it's very collaborative, more so than I thought it would be, and it's amazing. So I want to be a scientist because it's really one of those areas where you can create anything you want at all. In science, there is no limit. Being a scientist means you have to ask these questions that no one has ever asked before. You might encounter a lot of resistance being, oh, you can't do that, or that's not possible. But there is no limit with science. It's never, I can't do this, it's how I can do this. It gives me an opportunity to create something not only for myself, but for everyone around me. Science isn't just about the researcher, it's about what you can do for other people with your work. And that's something really amazing to me, that you can create something that could benefit so many people, not just here, not just in this country, but across the world.